Good morning, aspirant. Hope you all are doing well, your days are going productive, and you are doing excellent in your studies. We are going to start a new course. In this course, you will be understanding from basic to very advanced level of quantum mechanics or quantum chemistry. If you follow this course from lecture 1 up to the end, I can guarantee you that after completion of this result, you will be master in quantum and you will be understanding each and everything with not much of complication. So this will be a great journey with you to teach you quantum. So let's get started. Our pace will be very slow. One thing you have to contribute me. I am contributing you the lecture, and in return, you will contribute me just patience, because in a very slow pace, understanding each and every concept, each and every mathematical expression we will be observing, each and everything I will derive in front of you, and we will be understanding quantum with different stories involved in its discovery. So let's get started. Before that, this is a basic introduction about me, and okay, so let's get started. This lecture will be a very basic lecture. uh, from upcoming in this lecture, basically I will be telling you that what exactly what things we are going to cover with time. Okay, so first we will understand. Here I am just writing what things we are going to learn in this entire course. First we will learn a bit mathematics, because quantum mechanics and quantum chemistry is uh, you know there are so much mathematics involved. Okay, so math, then we will be understanding a concept of math, that is operator operator, then function. We will be understanding this. Next, one very interesting thing about this math operator and function. Erwin Schrodinger once he was with his girlfriend, and they were in the beach, and just they were chilling and having some. They were chilling and they were just in their relaxed mode. They were on the vacation. Then suddenly Schrodinger recalled a equation. Okay, Schrodinger recalled an equation that solved a mathematical problem that he was trying to solve from past few months. And then Schrodinger said that uh, it would be better if I would learn math a bit better in my graduation. Okay, so uh, just a little bit funny thing. Math operator function, then we'll be understanding eigenvalue and eigenfunction, eigenvalue and eigenfunction. In my point of view, these things are very much related to these mathematical things, are very much related to a bit of spiritualism, and I will be discussing my point of views regarding this with you also. Okay, then what what is Hermitian operator? What is Hermitian operator? Third, we will be looking at normalization and probability probability. Very basic thing I will just want to discuss first. First it was thought that yes, light or electron, these are particle. Then it was a few experiment shows that no, these are not particle, these are basically wave. After that, someone said that no, these are neither particle nor wave, these basically has dual nature. Then somebody said no, there is nothing called dual nature, everything emerge itself in term of probability. Everything is a probability. Okay, so we will be listening to that story too in this journey. Now, 4, expectation value. expectation value expectation value and quantum mechanics postulates. Postulates means the basic fundamentals of quantum. 5, particle in one dimension box. Particle in one dimension box, or particle in one dimension box, then we will be continuing to particle in two dimensional box, particle in three dimensional box. This is combinedly, this is called particle in a box concept. Then 6, we will be discussing hydrogen atom. That is the most fundamental application of quantum mechanical postulates. Then we'll be looking at rigid rotors, rigid rotor model. So much physics is involved here, rigid rotor. Then 8, simple harmonic oscillator. There also so much physics is involved. Then 9, superposition principle. Superposition principle. Superposition principle. Next 10, potential barriers. Potential barriers. Basically, this is called tunneling. Potential barriers, this is called tunneling. Very much interesting and very much motivating things for us. In this way particle behaves. Actually, tunneling is doing something. You have less energy for doing something, but still you can do that. Okay, so for example, you have 5 units of energy, but we have to perform a function of 50 units of energy. You do not have that, but sometimes in quantum mechanical particle do that too. We will be understanding the different models of this tunneling, and this is not just a theoretical concept. Based on this tunneling concept, this is a purely quantum mechanical phenomena. We have one microscope that is called scanning tunneling microscope, based on this principle. Okay, now 11, two methods: perturbation method, perturbation method. 12, variation method. Just take a pen and notebook and just keep writing with me, and after the whole course we will be have very beautiful notes of quantum, and you are going to enjoy that throughout your entire life. 13, LLP. I'll be talking that when we will study that. 14, HMOT. Then 15, molecular orbital theory, valence bond theory. 16, we'll be talking about spin. Okay, so these are all the things we are going to discuss one by one. As this is a very introductory lecture, I will be just throwing some information to you and some basic stories about quantum mechanics, that how all the things started. First we are going to scientists or chemists or physicists, they tried to understand our mother nature, and they realized that how everything is made. So first we know that Dalton's atomic model came, in the year 1815. What we get? Dalton's atomic model. that everything is made up of atom, right? Dalton's atomic model. So everything is made up of atom. Now 1887, then actually fundamental particles were derived, and we find that no atom, we can also break atoms, right? Then in 1887 we got photoelectric effect. Photoelectric effect. And with this photoelectric effect, and after that we found something called black body radiation. Black body radiation. Black body radiation. With this photoelectric effect and black body radiation, one thing we get confirmed, that light is a particle. Light is a particle. Okay. Okay, then in 1900, Max Planck said that energy, Max Planck said, this energy is not continuous. Energy is not continuous. Energy is basically discrete and comes in the form of packets. Each packet has energy of nh nu. Okay. So energy is basically what Planck said, that energy is quantized. Quantized. What does the word quantized mean? Quantized means it's not continuous, it's discrete. Okay. Now in 1905, Albert Einstein, in the Planck's, this theory is called Planck's quantum theory, and from this is the basic or fundamental of quantum, from where quantum basically started. Okay. In 1905, Einstein explained photoelectric effect, okay, with different equations and all, with threshold energy explanation and these things. This photoelectric effect was beautifully explained by Albert Einstein, and after that different discoveries happened in this zone. So here it was discovered that light is a particle. Now there was another experiment that is called Young's double slit experiment. Young's double slit experiment. Suppose there are two slits here, 2 points here from where something can pass. If I pass one ball from here, if I throw many balls from here, what will happen? There's a few balls will go there and hit in the wall. So we will be getting the hitting mark of ball at this point and this point. So this thing happen if this, what we have initiated, it is particle. But when we throw light here, when we put light here instead of some balls, we found that there are, it's like this is emitting from this slit like this, and here we are getting light dark interference pattern. That basically confirms that light is a wave. Light is a wave. And with time, with its extension, what was observed? That electron, photoelectric effect also proves that electron is particle. Photoelectric effect and black body radiation both confirms that electron is a particle. But This Young's double slit experiment confirms that it is a wave. This same phenomena is observed when we bombard electron from here. Interference pattern is noticed. So Young's double slit experiment said no, electron is a wave. And then in 1923, de Broglie said that yes, electron has dual nature. Sometimes it exists as particle, it represents itself as particle, sometimes as wave. So dual nature of particle, lambda equal to lambda de Broglie wavelength equal to h by mv. This formula he gave us. So de Broglie said electron is wave plus particle both. Okay. Now in 1925, Schrödinger gave his famous wave equation. We will be understanding each and everything in detail, but here just one timeline to make you to give you a better clear picture. Wave function. So Schrödinger gave wave function in 1925. Then in 1927, Heisenberg gives Heisenberg uncertainty principle. Heisenberg uncertainty principle. Okay. So these are very basic discoveries of related to quantum mechanics. I am okay. A second. This Young's double slit experiment, and there is another thing, that is diffraction. Both this thing prove that yes, electron is wave, and photoelectric effect and black body radiation, that basically proves that wave electron is a particle, and this is the same for light. And later on we have seen that light is basically the particle called photon, right? So everything has dual nature. When we are observing this, when in photoelectric effect and black body radiation, it is representing itself as particle, and in this case it is representing itself as wave. Okay, and this is a huge mystery of science till date, that what influence of any fundamental particle to behave as a particle or as a wave. What is basically influencing them? Okay, that's very interesting and mysterious thing. Okay, so in the next class, in the next lecture, we will be I will be teaching you that mathematics involved in quantum mechanics. If you are not in not good at mathematics, don't get afraid. I will be writing each and every formula we are going to use, each and every integration method we are going to use, each and everything integration difference, each and everything I will be writing with you. Okay, so you will have no problem. Mathematics, next lecture we will be seeing that mathematics involved in quantum mechanics. Mathematics involved in quantum mechanics, and this you can call it as unit 1 of our discussion. Unit 1. In unit 1 there will be many topic. One of this topic is, first topic you can say, is mathematics involved in quantum mechanics. With this we will start our next